The textile dye industry is a major chemical-based industry that plays an important role in producing colored products for clothing, upholstery, leather products, paper, and plastics.
Among these applications, the textile industry is the largest consumer of synthetic dyes due to the high global demand for colored textile.
During the dyeing process, large amount of water is required to dissolve the dyes and fix them onto fabric fibers.
However, not all dye molecules successfully bind to the fabric. A significant portion of unused dye is discharged together with wastewater, forming what is known as industrial dye effluent.
If this color wastewater is released into the environment without a proper treatment, it can cause serious water pollution and pose risks to the ecosystem and human health.
Most industrial dyes are synthetic organic compounds designed to be chemically stable and resistant to fading caused by light, heat, and washing.
One of the most widely used class of dyes is azo dyes, which contain the azo functional group represented by a nitrogen to nitrogen double bond.
Due to their strong molecular stability and high water solubility, dye molecules are very difficult to remove from water.
In wastewater conditions with low oxygen levels, azo dyes may undergo reduction reactions that break the azo bond and form aromatic amines. These aromatic amines are particularly concerning because many of them are toxic, mutagenic, and potentially carcinogenic.
One of the most visible environmental impacts of industrial dye effluents is the intense coloration of rivers and streams, even at very low dye concentrations.
The colored water blocks sunlight from penetrating deeper into the water, which inhibits photosynthesis in aquatic plants and algae.
Toxic dye compounds and their breakdown products can directly harm aquatic life, such as fish and invertebrates, while long-term exposure may cause bioaccumulation and genetic damage.
For human, untreated dye addition can contaminate water sources used for drinking, irrigation, and daily activities, increasing long-term human health risks for nearby communities.
A real-life example of industrial dye effluent pollution can be seen through the Noyan River, which flows through Tirupur region.
Tirupur is a major textile production hub, where many small-scale dyeing units generate large volumes of wastewater during fabric processing.
For many years, wastewater containing synthetic dyes discharged into the Noyan River with insufficient treatment. This scenario will causing severe coloration and deterioration of water quality.
This case study is supported by scientific study titled A Case Study on the Impact of Dyeing and Textile Industry on Noyan River Quality, Tirupur, conducted by Ajib Babu, Prakash Sainayan, and Abhinayan as in October 2017. The study reported high chemical oxygen demand, increased salinity, and poor dissolved oxygen level, indicating serious chemical pollution from textile dye influence.
As a result, aquatic life declined, groundwater quality deteriorated, and agricultural activities in surrounding areas were negatively affected. To reduce the environmental impact of dye effluents, several wastewater treatment methods are currently employed by industries.
One common method is adsorption, where activated carbon is used to attract and trap dye molecules on its surface through physical interaction.
Instead of adsorption method, there's another method which is coagulation and flocculation, which involves adding chemicals to neutralize the charge of dye particles, allowing them to clump together and settle out of the water.
Advanced oxidation processes such as ozonation and the Fenton reaction generate highly reactive hydroxy radicals that chemically break down dye molecules into less harmful substances. Future solutions include biodegradable dyes, enzyme-based treatment technology, stricter wastewater regulation, and closed-loop water recycling system in textile industry.
While dyes add color and vibrancy to our daily life, the improper disposal can leave long-lasting damage to the environment.
By improving wastewater treatment methods and encouraging environmentally friendly industrial practices, the negative impacts of dye effluents can be significantly reduced.
Chemistry plays a crucial role not only in industrial development, but also in protecting the environment for future generations.